Hey guys, let me expand this real quick. Alright, domain and range, that's the lesson for today. Okay, domain and range, one of those letters is X, one of them is going to be Y, and the way I remember it, well, it's not working for me. The way I remember it is that domain, the letter D, comes before R, range, in the alphabet, and X comes before Y. So do me a favor and write here under the title, I want you to under domain write X and under range write Y. Alright, also remember that f of x is just another way of writing y in function notation. Okay, so whenever we were trying to find range, whenever you were answering questions about range, you're using this axis to determine. And if you're going to be answering questions about the domain, you're going to be using this axis. So domain X, range Y. Another way I like to think of it is domain is asking how wide a graph is, and range is asking how tall. Just another way of thinking about it. All right. Okay, on this graph, I'm going to just highlight my points for you so we can see them a little bit better. I use pink. So there they are. And let's go ahead and find our x's of each point, because that would be the domain. So I want to trace each of these to the x-axis. Well, the x-axis would be down. Okay, so here's our origin. So this x value is back 1, so that would be a -1. Go on to the second point, trace that down to the x-axis. This is the origin, so that would be x is 1. Okay, now let's do this third point, trace it to the x-axis. Here's the origin, so that's x is 1, 2, 3. And notice this fourth point would be exactly the same on the x-axis, so another 3. Now let's do our y, the range. So we're going to trace them. So we started, let's go in the same exact order. This point, let's trace it to the y-axis. So if this is the origin, that's 1, 2, 3, 4. This is the point we did second, so let's trace it to the y-axis. Here's the origin, that's 1, 2. Okay, next we did this point, so let's trace it to the y-axis. Here's the origin, it's down 1, so that's -1. And then our fourth point, trace it to the y-axis. So that's down 1, 2, 3, that's -3. So I know the x values represent the domain, and the y values represent the range. Okay, so domain, the way we want to write it, whenever there's points, this is what you call discrete. You have discrete and you have continuous. The difference between those is continuous is continued with a line segment. Discrete is just individual points. You see there's no line connecting these points? If there was a line connecting them, that would be continuous because the graph continues. But as you can see here, the graph does not continue. It's only here at the individual points. Okay, so whenever it is discrete, all we have to do is list. So for our domain, I'm going to make these little, I'm really bad at them, these little curly Q brackets. Third time's the charm. Okay, that's good enough. It's a little curly Q bracket, and what we're going to do is we're going to list our x values for the domain. And you always want to do them in numerical order. So -1 first, then 1, then 3. And you don't have to repeat this second 3. And close your brackets. So I know my domain includes x's of -1, 1, and 3. All right, now let's do our range, which is our y's, so we're going to list them. And to be proper, we want to put them in numerical order, so the smallest number is -3. The next smallest number is -1, then 2, then 4. Close your brackets. So range, when it's a discrete graph, all you have to do is list the y values. Okay, this part of the question right here is like a throwback from yesterday's note, so let's see if we can remember. This whole thing, the whole thing means y, but the number inside of the parentheses is the x. So remember, this is read like evaluate f of -1 is just another way of writing y equals what when x is -1. So I'm going to go where x is -1. Well, here's the x-axis. Go back 1 because it's -1. And I have a point that is above it 1, 2, 3, 4 spaces. So I know my y value is 4 when x is -1. So notice, -1 on the x-axis. I move up 1, 2, 3, 4 to get to that point. So x is -1, the y value is 1, 2, 3, 4. So I know that y is equal to 4 when x is -1. Okay, lucky us on example 2 because we don't even have to fill in the table. Last one, we actually had to fill the table in ourselves. This time it's already done. So remember, domain is your x's. So all we have to do is list those x's. Remember, to do it proper, you want to do it in numerical order. Well, -2 is the smallest number, then 0, then 4, then 8. Oh, I need to get better at these brackets. So I know our domain includes x values of -2, 0, 4, and 8. Okay, remember, range, that's your y's. Okay, so now all we have to do is list our y values. So notice the only y value we have is a 1, and there's no need to repeat it. Oh, that was pretty good. That's more what they're supposed to look like. Let's try to fix this one. Alright, so I know my range includes y values of 1. Okay, so now let's evaluate f of 4. So remember, the whole thing means y, so I'm trying to figure out what does y equals, and the number in the parentheses is your x. So we're going to go to where x is 4. When x is 4, I know y is 1. Okay, this next one can be a little tough, especially if you don't know what this looks like. F of x equals 10. Well, first what I want you to, us to do is graph it so we have an idea of what does it actually look like. Move this guy over some. Okay, new document. We never save. I'm going to go to a graph, and I'm going to type in 10 and click enter. Well, I typed in 10, I clicked enter, and nothing showed up. Okay, well guys, just because you can't see it doesn't mean it's not there. Notice this goes from, on the x-axis, 10 to -10. On the y-axis, it only goes to about -7 to +7. So that's a pretty small screen. So just because I can't see it doesn't mean it's not there. So what I'm going to do is zoom out until I can see it. So to zoom, you go click the menu button. Then you go to where it says Window, Zoom, and we're going to zoom out. hover this little magnifying glass over the origin and then click enter. And if you need to zoom out again, you could click enter again, but I can already see it. I see my graph is right here, so there's no need to do that. Alright, so now that I have an idea of what it looks like, let's take this and let's go sketch a picture of it on our notes. Okay, so I drew my x and my y axis, and then my graph was a horizontal line. So that's what f of x equals 10 looks like as a graph. Okay, so for domain, I need to figure out how far it goes to the left and how far it goes to the right, aka how wide is it? And those are your x values. Okay, well on this graph, this one is what you call continuous because it is continued on a solid line, right? So it's continuous. Alright, so if I look at this graph, there is nothing that's going to stop it from going to the left direction. It goes on and on and on and on. And if I trace this line to the right, it will also continue. So there is no stopping it in the left direction. There is no stopping it in the right direction. Remember, we're checking left and right because domain is x. The x-axis goes left and right. So when there's no stopping it to the left and there's no stopping it to the right, there's no stopping at all. What we call that is all real numbers. And the way that we write that is like this. It's like an R with the double extra line. I'll write it a little better. All real numbers, which means it's going to go forever left, forever right. So the domain will go on forever and ever. Okay, remember your range is your y's, and your y-axis goes up and down. So we're talking about how high it is and how low it is, okay? So if you notice, our line is a horizontal line. So it never gets any higher than right here, and it never gets any lower than right here. Well, how high was it? Well, this is where this one kind of makes a lot of sense we know that this f of x means y. Look what that says, y equals 10. So I know it's crossing the y-axis at 10. So this entire line, no matter where I'm at, is at a height of 10. It never goes any higher than 10. It never goes any lower than 10. The only height I have is at 10. So my range is only 10. It's going to be at that height forever and ever. No matter where I am on that line, the height is at 10. It's never higher. It's never lower. It's always exactly at the height of 10. Okay, so now we try to evaluate f of 8. Remember, that's asking what does y equals when x is 8? Zoom in real quick so I can write. Okay, so if you're not sure on how to do this, remember we can always use our graph to help us. So I want to figure out when x is 8. Well, we already graphed this, so I'm going to go back to it. Here's my graph. Remember from yesterday we do menu, trace, graph trace. So notice it looks like an x. So I could type in any x value. Well, the x value I want to jump to is 8, so I type 8 and click enter. When x is 8, my y value is 10. And that should make sense because we just said no matter where we're at, the y value will always be 10. Okay, back to a little bit easier of a problem. Okay, this is discrete again. It's not continuous. It doesn't have the continuing line, right? So we like these. These are nice. Okay, so domain is our x's. So whenever it's discrete, nice and easy, all we have to do is list our x values inside of our brackets. So remember, you want to start with the smallest number, where the smallest x value is -7, then -2, then 0, then 5. So all you have to do is list your x values. So our domain consists of x's of -7, -2, 0, and 5. Okay, range, that's y. You might want to even put a little y above f of x, just to remind us that f of x just means y. Okay, so now all we have to do is list our y values. Remember, you want to do the in numerical order. So -9 first, then -4, then -1. So our range consists of y values of -9, -4, and -1. Okay, so now we want to evaluate f of 5. So remember, we're trying to figure out what does y equals when x is 5. So I'm going to go where x is 5 and follow that arrow. When x is 5, I know y was -9. Okay. All right, back to graphs. Notice this is continuous. I know it's continuous because it has the continuing line, so I don't get to just list. All right, domain. That's our x's, so I'm using these numbers to do domain. Domain is the x's, correct? So those are the numbers I use. Okay, so domain is asking how wide is the graph? All right, so I know my graph starts right here, so if I trace that down to the x-axis, I know that is at 0, so I'm going to put that 0 real quick for now. And then I know my graph goes all the way to the right. This is as far as it goes to the right, which is here, and that is at, oops, I need to make it a little bigger. Five. So I know it went from 0 to 5. Okay, so started over where x is 0, and it comes all the way over here to where x is 5, and it's everything in between because it's continuing right here. Okay, so we need to use, put an x right here in the middle because domain is x. I know all my x's are between 0 and 5. Then what we need to do, since you always start with the small number, we always go left to right. I know we're going to use less than symbols on both sides, exactly the same. 0 is less than x, which is less than 5. They both need to be less than symbols because you're always going to start with the small number, end with the big number because we always go left to right. Okay, so now we have to decide if underneath should we put the or equal line or not. Okay, and the way you decide is over here by 0, you see this circle? It's an open circle. So open circle, leave the line off. Remember, solid line, solid circle. So this one, I do not want the line underneath by 0 because it is open. But if I go over here wherever x was 5, notice that's a solid circle. Solid circle gets the solid line. So over by 5, you need to put the solid line because it's included. All right, range. Range is your y's, so this time we want to use these numbers. So range is talking about how far up and how far down the graph goes. So you want to go bottom to top. Well, here's my graph. The lowest it goes is right here. This point is the lowest point on this entire little piece of graph. So I need to trace this point over to my y-axis. So I know that would be 0. Okay, now I need to find the highest. So on this little graph, the highest is right here. So I need to trace that over to the y-axis. That's as good as it's going to get. So here, over here, so the highest it goes is 4. So the lowest the graph went was here, which was at a height of 0. The highest the graph goes here, which is a height of 4. Remember, we're using these numbers. Okay, and since it's continuous, I know my graph is everywhere in between there, so I'm going to put my y, range as y, in the middle. Since we always go bottom to top, the small number should be first, so we're going to use less than symbols on both sides. Now we decide, do we put the or equal sign underneath or not? So let's go down to where the height was 0, the lowest point. Notice that was a solid circle, so you want the solid line. Okay, go to the highest point. Up here at a height of 4, notice there is not an open circle here. That is a solid line at a height of 4. So solid line gets a solid line. Alright, so let's evaluate f of 2. So I'm trying to figure out what does y equals when x is 2. So when x is 2, 1, 2, x is 2 here. Now we have to go to our graph. When x is 2, that's at a height of 4. So we know when x is 2, the y value is 4. All right, example 6. Domain. And for domain, we use the x's, so we're going to use this axis, to get our numbers from. Remember, domain is x's, and that's left and right. Okay, we always go from the left to the right. Okay, so this right here is the farthest the graph. Here's my graph. It means it starts here, and it's going to go forever. That arrow means go forever. So my graph is starting here, and it's going to go in this direction forever. All right, so the farthest my graph can go to the left is this point right here. So that's at -2. Notice, there is no stopping it to going to the right. It's going to go in the right direction forever. Okay, so when you only have one stopping point, we're going to start with our x, because we don't have two between numbers, so I'm going to start with x. And notice the direction it's going. It starts at -2, and it's going to go forever to the right. So if it's going to the right, we have to decide, should I use a greater than or a less than? So if it goes to the right, the number should be getting larger, so that's greater than. So it starts here, x is -2. It's moving in this direction. All your x values are getting larger, so x's are greater than that -2. Okay, now we have to decide, do I put the or equal sign underneath? So go to where x was -2. That was a solid circle, so we put the solid line, because -2 is included. Alright, range is y, which is this axis. So we're talking about the highest and the low it goes. So if you're looking at this, notice it's at the exact same height the entire time. It never goes higher, it never goes lower. So we have to figure out what height is this. So that crosses the y-axis right there. So here's my origin, that is down 1, which is a -1, and that's the only height it is. It's the same height all the way across, right? So my range is only -1. Or you could put y equals -1, either one. Okay, so now let's evaluate f of -1. So remember to read this as, what does y equals when x is -1? So I'm going to go to where x is -1. Here's the origin. go back 1, that's x is negative 1. So x is negative 1, follow it to your graph. That's at a height of negative 1. And that should make sense because it's at the exact same height the whole time. Your y's never change. The whole way it's the same height. Alright, another continuous one because it's a continuing line. Domain. So we're going to use this x-axis to figure out domain. So we're looking left to right. Okay, so if you see this graph, here we go. Boom, this is the graph it's talking about, right? So notice as I follow it this way, there's an arrow. That means it's going to go forever and ever and ever. If I follow it the other way, boom, on the other end I have another arrow, which means it's going to continue forever in that direction as well. Okay, so let's pretend that we have this is a string and I have a ball on it, like a little bead. Okay, so if this was a little string, and let's say this was a bead, if I grab this bead and moved it in this direction to the left, it would just keep going and going and going, so it will never stop going to the left. Alright, so let's drag it back, going to the right, following it to the right. As we go to the right, it goes and it goes and it goes and it goes. So there's no stopping it to the left, there's no stopping it to the right, so when that happens, we say there's all real numbers because it will go forever left, forever right. Range, remember range, you use this axis, the y-axis. So remember range, you're trying to figure out how far up and down it goes. We go bottom to top. So we have to figure out where is the lowest point on this graph, and this is the lowest point, so I'm going to trace it over to the y-axis. Well, here's the origin, so it's down 1, 2, 3, 4. That's negative 4. Okay, now let's see how high it goes. So as I go to the top, I notice that there's an arrow, which means it's going to go up forever and ever. So there's only one stopping point. So since there's only one stopping point, I put my y out front. Range is y. And now I have to decide whether to use a greater than or less than symbol. Well, it starts here, and notice the graph is going up. So if the graph is going up, greater than makes sense for up. Less than would be down. So it starts at negative 4, and goes up forever. So as you go up, the numbers get greater. Alright, now we have to decide, do I put an or equal line underneath here? So go to your height of negative 4. Notice that was a solid circle, so we put this solid line. Alright, so we're going to evaluate f of 0 now. Remember to read this as, what does y equal when x is 0? So we're going to go to where x is 0, just here, at the origin, and trace it till we get to our graph. I have to go down. Boom. Here. So when x is 0, my y is down 1, 2, 3. Down 3 is negative 3. Alright, almost there. Domain again. Domain, we use the x-axis, so we're using these numbers left and right. So here's my graph. Notice as I go to the left, travel along going in the left direction, I see an arrow, which means it will go forever and ever. Now let's try the right. As I go to the right, I see an arrow, which means it will go to the right forever and ever. There's no stopping it in either direction, so we call that all real numbers. Alright, range, up and down, so we use those. So we go lowest to highest. As I go down on my graph, notice there's an arrow, so it will go down forever and ever. As I go up, there's another arrow, so it goes up forever and ever. No stopping in either direction is all real numbers. So there's no stopping that graph at all. It'll go forever and ever. Okay. It says, what is the range of the function f of x is equal to 2x plus 7 when the domain, remember that's x's, is 2, 4, and 6. So what we're going to do on this one is we're going to go graph 2x plus 7. And we're going to use trace because trace lets us jump to our x values. Alright, so we're going to go add a new calculator. Never save. And the equation it gave me is 2x plus 7. Enter. I know I have x values, so we use trace, menu, trace, graph trace. Notice it looks like an x. So I can jump to any x values. The first x value I want to jump to is 2. So let's go ahead and write that point down. 2, 11. Alright, now I want to jump to where x is 4. So I'm going to type in 4, click enter, write that point down. 4, 15. And lastly, we want to jump to where x is 6. So type in 6, click enter, write that down. Okay, this problem is asking about the range, which is your y's. These are your y values. So we're going to list them in numerical order. So 11, then 15, then 19. Last problem. In this problem, it asks, what is the domain of the function f of x equals x plus 4 when the range is 5, 8, and 13? So this time it gave me y values. So we can't jump to y, so I'm going to show you another way to do this one. Okay, so same idea, we're going to go to the graph and graph x plus 4. So x plus 4. Okay, I can't use trace because remember trace looks like an x. We jump to x values. Well, these are y values. We don't jump to y's. So if I want to look at y values, I'm going to open a table. Well, to open a table, you press Control, and table starts with T. So Control T. Okay, this is what the table looks like. Notice this first column has an x, so these are your x values. This next column says f of x. Those are your y's. So we're looking in the second column for our y values. The first y value I want to look at is 5. Notice it popped up right away. So this is y is 5. When y is 5, x is 1. So I'm going to write that as a coordinate point. So 1, 5. The next y value I want to look up is 8. So remember the second column is your y's. Well, here's y is 8. So when y is 8, x is 4. So let's write that as a point. 4, 8. And the last y value it wants me to find is 13. So remember your y's are in the second column, so I'm going to scroll till I find 13. Found it. So when y is 13, x is 9, so let's write that as a coordinate, 9, 13. So the key word on here is domain. Domain, remember, is your x values. That's these guys. So I'm going to list them in numerical order. So 1, 4, 9. And that's it. Oops, I should have bracketed that. All right. Later, guys.